My name is Omar Ahmed. I am a computer engineering student currently living in Maadi. I aspire to be a data engineer, and today we will finally figure out what a data warehouse is and why it's crucial for businesses. Let's dive in. What is a data warehouse? Let's start with the foundational Bill Inman, widely recognized as the father of data warehousing. He defines a data warehouse as a subject-oriented, integrated, time-variant, and non-volatile collection of data in support of management's decision-making process. This means subject-oriented is that data is organized around a key subject, such as customers or sales. Integrated refers to that the data is all in one place, consolidated in the same format. Time variant means that shows changes over time, providing historical context. Non-volatile indicates that once data is entered, it doesn't change. It's stable and reliable, acting as a single source of data truth. Understanding these helps us appreciate the role and importance of a data warehouse. Now let's talk about traditional ELT-based data warehouses. This process involves extracting data from various source systems, transforming the data into a suitable format for analysis, which includes cleaning, aggregating, and modifying it, and then loading the transformed data into the data warehouse. This method has been widely used for many years and is effective for ensuring data quality and consistency. However, it can be time-consuming and resource-intensive because the transformation step happens before loading data into the warehouse. In contrast, modern data warehouses often use the ELT approach, extracting data from various source systems, directly loading it into the data warehouse, and then transforming the data within the data warehouse itself. This leverages the application resources of modern data warehouses, which makes transformations more efficient. A prominent example of ELT-based data warehouse is Amazon Redshift. Redshift allows for massive parallel processing, enabling quick loading and transformation. By loading raw data directly into Redshift, businesses can analyze their data almost immediately, and transformations are applied as needed. This is more flexible, which makes ELT a popular choice for modern data warehousing solutions. There is a distinction that needs to be made between online transaction processing systems, since they manage daily transactions like sales, inventory updates, while data warehouses store historical data for in-depth analysis to uncover trends and make strategic decisions. Both are essentials, transaction databases for operations and data warehouses for business insight. Now let's talk about the different ways data is organized in a warehouse. Let's start with the star schema. It's a simple data warehouse structure with a central fact table containing metrics for analysis like sales revenue. Surrounding this are dimension tables that provide descriptive context about the facts, such as details, store locations, and dates. While easy to understand and query, it can lead to data redundancy since dimensions are denormalized. Next, we have the snowflake schema. It's a more complex version of the star schema, where dimension tables are normalized, meaning they are broken down into multiple related tables. The fact table is the same as, but the normalized dimension tables split into multiple related tables to reduce redundancy and improve integrity. While the snowflake schema can save storage and space and maintain integrity, it also makes queries more complicated because of multiple joins required. Finally, let's discuss the Galaxy schema, also known as a fact constellation schema. This schema is used for more complex data warehouse designs that need to handle multiple fact tables sharing dimensions, each representing different business processes or subjects. The shared dimension tables are common across different fact tables. It's highly flexible and can support complex queries across multiple business processes. However, it's challenging to design and maintain due to its complexity. Now let's look at how data warehousing is used in the real world. Analyzing operational data. Uses data warehousing to optimize drilling operations and reduce downtime. Optimizing supply chain. ExxonMobil monitors and optimizes their supply chain, reducing logistical costs. Improving maintenance strategies. BP tracks equipment performance to predict maintenance needs, preventing failures and improving safety. Managing energy production data. Next era consolidates data from various sources to balance supply and demand effectively. Analyzing customer energy usage. Duke Energy analyzes usage patterns to offer personalized energy saving recommendations. Enhancing project planning. Iberdrola uses data warehousing to plan renewable energy projects efficiently, improving timelines and reducing costs. Thank you so much for your time and attention. I'm excited about the opportunity to contribute to Raisa Energy as a data engineering intern. I look forward to discussing how my skills and passion for data can benefit your team. Feel free to ask me any questions. My sources can be found here and in the description of the video. Thank you.